So let's walk through some exercises here so we can practice making our statements of the hypothesis and see where we can go with that. So in the first example, the packaging on a light bulb says it should last 500 hours. Consumer Reports wants to know if the mean lifetime is actually less than that. So what's the parameter in this case? Well, in this case, we're talking about the mean lifetime of a light bulb. So we're going to be thinking about the population mean. And so our parameter here would be the mean lifetime of a bulb. What do they say? So what they're asking for there is what the status quo is. In this case, the packaging on a light bulb says it should last 500 hours. So what they're saying to us is that mu should equal 500. But what we want to know is it really less than that? And so what type of test is this? Well, this is going to be a left tail test because we're involving the less than symbol. Right here we have our null hypothesis and our alternative hypothesis. Let's read the next example. The standard deviation of the rate of return for some mutual funds is 0.08. A manager believes the standard deviation might be higher than that. And here we're making a statement about a standard deviation. So we'll use the symbol sigma. And in this case, it's the standard deviation of the rate of return for so I'll say standard deviation of rate of return for some mutual funds. Now, they're telling us here that it's 0.08%, but a manager might believe that it might be actually higher than that. So what we're told is that it's 0.08, but what we want to test is whether or not it's actually higher than 0.08. And again, here we've got our null hypothesis and our alternative hypothesis. And because this alternative hypothesis involves the greater than symbol, this will be a right tail. According to a Gallup poll in 2008, 80% of Americans felt satisfied with the way things are going in their lives. A researcher wonders if the percentage is different now. Now notice here we're looking at a percentage of Americans that felt satisfied with the way things are going in their life. So here we're talking about a proportion. So here P represents a proportion of Americans who feel satisfied with their life. And so now we're given that according to a poll in 2008, that value should be 80%. So the proportion would be 0.80. But we're wondering now if things have changed since 2008, if that proportion is different now. So in other words, It's not indicating if it's less than or greater than, but just not equal to what it used to be. So in this case, because we're using the not equal to symbol, it'll be the two-tailed test. And so there we have, again, the null hypothesis and the alternative hypothesis. And so, depending on what we get, there could be two correct ways to draw a conclusion here. Because for the most part, the claim that we're making means that either the null hypothesis is true or the alternative hypothesis is true. And when we make a decision or when we draw a conclusion, for instance here in the case when we decide there is evidence to support H1, there is evidence to support the alternative hypothesis, that means that the null hypothesis was false. So if we decide there is evidence to support H1, then that'll be correct in the case when H0 is not true. And then when we decide there is not enough evidence to support H1, and that'll be correct when H0 is true, when the null hypothesis is true. So let's consider what happens here in the case when we either reject or don't reject our null hypothesis. So historically, Jimbo's Pizza had a mean delivery time of 48 minutes. After getting a new pizza oven, he takes a sample of 50 orders and finds that the mean delivery time is now 45 minutes, which makes Jimbo think that the mean delivery time has been reduced. So let's use the description here to state what our null hypothesis and what our alternative hypothesis would be in this case. So historically, Jimbo's Pizza had a mean delivery time of 48 minutes. So this would be the assumption that we're making is that the mean is equal to 48. But according to some data that he's collected some data from 50 orders that shows that the time is a little bit lower on those 50 orders. So he wants to know if that mean delivery time is actually less than 48. Now let's think about what we can conclude depending on whether or not we decide we're going to reject the null hypothesis. So the process from this point would be then to use the sample data that we've collected, in this case the mean of those 50 orders in the sample was 45 minutes. And so what we would need to figure out now is how likely that is to occur if the mean was really equal to 48. So if we reject the null hypothesis, what we're saying is really that the alternative hypothesis is true. So then the evidence supports the alternative hypothesis. That mu is actually less than 48. On the other hand, state the conclusion if the null is not rejected, and In this case, then we would say that there is not enough evidence to support the alternative. But what we have to be careful with here is, even though we're saying that the alternative is not supported, it doesn't necessarily support the null hypothesis either. So really, this is an inconclusive result. So the only case when we will have a conclusive result is when we reject the null hypothesis. In this example, we're going to look at the different types of errors that could arise when we perform a hypothesis test. So in this case, we're looking at a particular court case. Here the null hypothesis is that the defendant is innocent, and the alternative hypothesis is that the defendant is guilty. So the four possibilities are that we fail to reject the null hypothesis when the null hypothesis is true. We fail to reject the null hypothesis when the null hypothesis is false. Or we reject the null hypothesis when it's true, and we reject the null hypothesis when it's false. So between these four different outcomes, which ones are going to be the ones where we have made an error? And let's start with this first one, where we've failed to reject H0 when H0 is in fact true. So in this case, the defendant is innocent, is what we're saying here, is that if H0 is true, then he's innocent, is what that's saying. But if we fail to reject H0, okay, in other words, we're not rejecting that he's innocent. In other words, we're concluding that he's not guilty. That's kind of the important way to word it here. We're saying he's not necessarily guilty, okay, when in fact he is innocent. So this looks like this would be okay because there was no error made here. The result that we got was that he was not guilty when in fact he was innocent, and that seems to be in agreement. If we were to fail to reject the null hypothesis when in fact it's false, in other words, if the null hypothesis is false, that means the alternative hypothesis is true, and so the defendant would have to be guilty. And so the conclusion that we would draw here is again that he's not guilty because we're failing to reject it, but in fact he is guilty. So you see in this case we've made an error. Now the case when we do reject the null hypothesis, we're then saying that there is not enough evidence to support that he is innocent, so we're going to reject that claim. Okay, so we say that he is not innocent when we reject the null hypothesis. When in fact, here, if H0 is true, he is innocent. So here we've made a different type of error. that we've concluded that he's not innocent when in fact he was. And then in the case when we reject the null hypothesis, when the null hypothesis is in fact false. So the conclusion then, again, is that he's not innocent. When that's in fact true, that he is guilty. So he is not innocent. So here we were not making an error either. So we see that in these two cases, when we reject the null hypothesis when in fact it's true, we've made an error. And also when we fail to reject the null hypothesis when it's false, we've also made an error. And which of these two errors is more grave in this situation? Well, I guess it might depend on how you interpret it. So is it worse to declare somebody guilty when in fact they're innocent? Or is it worse to declare somebody not guilty when in fact they are guilty? Well, I might argue that it would be worse in this case to have this type of error, because then you would be sending an innocent person to jail. Versus this error here, where in a sense you're letting a guilty person go, but at least nobody is necessarily harmed here, other than the fact that you're letting a guilty person go. So maybe that guilty person would go on to do more crimes in the future. So depending on how you interpret this, you could consider one of these errors more serious than another.